So in this video, we're going to be looking further into projectile motion, but calculations involving a moving projectile. So let's get started. So we have a question here. An aircraft searching for a boat is flying horizontally 490 meters above water level. The aircraft has an initial speed of 60 meters per second, and the boat is spotted. When the boat is spotted, a life raft is deployed. So you need to find the time taken for the life raft to fall to the water, the horizontal distance from the boat that the aircraft must drop the life raft, and the velocity of the raft when it hits the water. So first things first, what I would do is I would draw a diagram of the situation so you know exactly what you're trying to picture in your head. So if you have a very dodgily drawn airplane, you have some water down here, and a boat. So aircraft at the moment is 490 meters above the water level. And it's flying with an initial speed in the horizontal direction at 60 meters per second. So we want to find the time taken for a life raft drop from the plane to hit the water. The only things we know currently are the horizontal velocity, the initial horizontal velocity, which I shall call V0H, represent horizontal. That's equal to 60 meters per second. Because we neglect the air resistance, the horizontal velocity is actually going to stay the same across the whole thing. So V initial and V final of the horizontal velocity doesn't really matter because it's going to be the same. So ultimately, I can just say that this is just VH. So my distance in the vertical direction is going to be equal to 490 meters. And I know, because this plane is travelling horizontally, I have absolutely zero vertical velocity. So I can call my vertical initial, so V0 for velocity 0, 0 meaning at time 0, so initially. So the velocity at time 0 in the vertical direction is going to be equal to 0 meters per second. So knowing these things, I need to find the time taken for the life raft to fall to the water. So I also know one other thing. The acceleration due to gravity is equal to 9.8 meters per second. For ease of, just for my ease, I'm going to call the downward motion, and define that as being positive. So that way my acceleration due to gravity is in a positive and not a negative. So I now know these bits of information. I'll then apply a formula. So we have three formulas that we can use. V is equal to V0 plus AT S is equal to half, S is equal to V naught T plus half AT squared. And we also have V squared take away U squared, V naught squared is equal to 2AS. So of these formulas, if I want to find out the time taken, if I know my vertical component of my vertical distance, if I know my vertical distance, I can apply it into this formula here. If I call S 490, V0 in the vertical direction 0, and A 9.8, I can rearrange to find T, which is what we want to do, find time taken. So I'll use this formula. I can't use this formula because I don't know the final velocity in the vertical component, and I can't use this one because I can't find out the time based on that. I want to find out time. So to work out which formula you need to use for what part of the question, basically if you write out everything you know and write out all the formulas, if you have two unknowns in the formula, you don't use that formula. If you only have one unknown in the formula, you can use that one because you want to find out that one unknown. In this case here, I've still got one unknown, which would be my V final, but I don't want to find out my final velocity at this stage. I want to find out time. So I won't do this one. I'll use this one. So if I know the formula, S is equal to V naught T plus half AT squared, and I know the S, the V0 and the A, I can substitute in for those letters the numbers that represent them. So my S in the vertical direction is 490 meters. My V0 in the vertical direction is 0. The reason I'm using the vertical direction is I'm using the distance from the vertical direction. So if I'm using already one unit from the vertical direction, I have to use all the other units from the vertical direction. So vertical direction distance, vertical direction initial velocity, which is equal to 0. I don't know T, so I'll leave that as a T. Add half is 0.5. I'll write half because it's easier. Half times by A is 9.8 meters per second squared. That's just a given because we're on Earth. It changes slightly depending on where you are, but if we round it up to two significant figures like we've got here, 9.8, this covers it all fairly well. So we've got 9.8 and we don't know time squared still, so it's T squared. Now hopefully you've all done enough mathematics to know that 0 times by anything is going to be 0. So this whole term here cancels out to 0. So if I now rewrite this again, without that term, because that just nulls itself out, I'm left with 490 meters is equal to half times by 9.8 -2, this is acceleration, times by t squared. So now the next step I want to do in getting t by itself in this formula is I want to get rid of the half. So if I have a half on this side of the equals, it's saying 1 divided by 2. If I want to put that on the other side of the formula, other side of the equals, instead of 1 divided by 2, it would change into 2 over 1. 2 over 1 is the same as saying 2 times something. So if I move from here to here, I get 2 times by 490 meters is equal to 9.8 times by t squared. So now I've got a times by 9.8 here. The opposite of timesing by something is divide by something if I move it across to this side. So I'm going to get 2 times by 490 meters. Divide that by 9.8 meters per second squared is equal to time squared. Now, the reason I keep putting these units in is to make sure I'm working this all out right. So I've got meters on the top and meters on the bottom. This will cancel each other out, because anything divided by itself is going to be 1. So meters and meters cancel each other out anyway. And we're left with seconds squared. Time is measured in seconds, but if I take the square root to get rid of the square on this side, it's going to be left with seconds on this side, so I know I'm working it out correctly. So t is equal to, in this case, the square root, get rid of the square, you take a square root, of 2 times by 490 over 9.8 seconds squared. So now if I put 2 times 490 divided by 9.8 in my calculator, I will get, so if I put all this in the calculator, what you get is 100. So the square root of 100. Square root of 100 is 10. So the answer is simply, if it lets me do it, 10 seconds. So part 1 was find the time taken for the life raft to fall to the water. The time taken was 10 seconds. So now we want to find the horizontal distance from the boat that the aircraft must drop the life raft. I'll change the colour for the next part of the question. How about that? So the next part is finding you the horizontal distance. So from the plane flying along, distance from there to the boat in the water. So this is dealing the horizontal direction now. So finding the distance of our projectile is also finding the range of our projectile. What we use to find out the distance travelled in the horizontal direction, because we don't have any acceleration, because we're dealing with a we're not dealing with any air resistance, we just use the simple formula of V is equal to S over T. Why is this playing up so much? So then when we rearrange this formula to find S, S is equal to V times by T. So I know that my horizontal velocity was 60 meters per second. So I can put that in here to find out my horizontal distance. And the time taken, doesn't matter if it's vertical or horizontal, the time taken is still going to be the time taken. So I'll put in my 10 seconds I just found out here into this question here. So my S in the horizontal direction is going to be equal to BH, which is 60, meters per second, times by 10 seconds. And straight away I can cancel out the 2 seconds and I'm left with meters, so I know I've got the right units here. And my horizontal distance is going to be 60 times 10, which is 600 meters. So the next part is find the velocity of the raft when it hits the water. Change colour again. So I now know the distance that it's travelled, 600 meters in the horizontal direction. I know the time taken, and I know the initial horizontal velocity, the initial vertical velocity, acceleration due to gravity, and how high it was. So to find out the velocity when the raft hits the water, I need to take into account both my horizontal and vertical components of my velocity. So knowing that V0 in the vertical direction is going to be equal to 0, because we already know that. And also knowing that my VH is going to be 60. And knowing the time taken was 10 seconds, and the acceleration due to gravity is 9.8 meters per second squared, I can work out, using this formula now, V is equal to, so V final is equal to V initial plus AT. So I'm going to deal with the final velocity of the vertical component. So I'll put in this number here for my V0. So my V final is going to be equal to 0 meters per second add A is going to be 9.8 meters per second squared, and T is going to be 10 seconds. So my final velocity is going to be 98 meters per second. Because I get rid of the squared by getting rid of that second there, I'm left with meters per second then. So now I know my two components, I can draw up a vector diagram to work out my resultant final velocity. So I have a horizontal component which is 60 meters per second long. I also have a vertical component which is 98 meters per second long. And I can use that information to find out two pieces of other information. One is my velocity resultant, and the other is the angle that it forms. So to work out my resultant velocity, I'm going to use Pythagoras to find out the length of this side. So Pythagoras is a squared plus b squared is equal to c squared. So this side squared at this side squared is equal to that side squared. So my VR squared is equal to 60 squared add 98 squared. To get rid of the squared, I take a square root, so my velocity resultant is equal to the square root of 60 squared add 98 squared. And my resultant velocity, if I chuck that in the calculator, is going to be, I have 114.9 meters per second. And now I need to work out the angle at which it is hitting the water at. So this angle here, below horizontal. So the way I can work that out is using these two sides and the tan ratio for trigonometry. So that's terrible. So tan theta is equal to the opposite side over the adjacent side. If I rearrange and substitute in for that, so my opposite side from the angle is 98 degrees, or 98 meters per second. My adjacent side is 60. And to find out the angle, take the arctan. And I find out my angle is going to be 98 divided by 60, 10, -1. The answer, it gives me 58.5 degrees. So now, to finish off this question, what I would say is that so the final velocity is equal to 115 meters per second, if I round it up to 3 significant figures. I need units there, ms -1, at 59 degrees below horizontal. So that's how we answered this question here. So I'll make some more videos on other questions, but this is long enough for the first question.